Welcome to the Explainer. Today we're looking at a totally new way to train AI. Forget the old methods of just giving it an answer key. We're talking about making AIs compete in what's basically a high-stakes sparring match. All right, so let's get right into it. This is one of the huge challenges in AI, right? We want these models to be creative geniuses, to write flawless code or draft up these perfect fact-checked biographies. But here's the problem. How on earth do you make sure they're actually correct, especially with something like code, where there are just endless possibilities and a million tiny rules they have to follow? So here's what we're going to do. We'll break down the core challenge, then we'll look at the old ways of doing things and why they don't quite work. After that, we'll get into this new, smarter game called RLAC, see how it plays out, and then, the best part, check out the amazing results. Okay, first things first. Let's really nail down the fundamental problem here. When you give an AI a complex job, there's not just one rule. There are tons, maybe even millions of rules it has to follow to get it right. So in the AI world, they call these rules rubrics. Just think of it like a checklist for grading a paper. For a biography, one rubric might be, did you get the birth year right? For a piece of code, it could be something like, hey, does this thing crash if you give it no input? Each little rule is a rubric. And this is the real kicker. You just can't check every single one. It's often impossible. For something like code, the number of potential gotchas or edge cases is basically infinite. And even for something you could check, like all the facts in a biography, well, doing that for every training example would be so slow and expensive that it's just not practical. Okay, so if checking everything is a no-go, what have we been doing up until now? Well, there have been two main approaches, but you know what? Both of them have some pretty big problems. So on one hand, you've got what's called exhaustive checking. This is the check everything approach. Super accurate, for sure, but like we said, crazy slow and costs a fortune. Then on the other hand, you have reward models. Think of this as hiring another AI to be a judge. It's way faster, but, and this is a big but, the AI being judged can learn how to cheat. It can trick the judge. This whole issue has a name. It's called reward hacking. The generator AI figures out how to get a good grade from the AI judge without actually getting better at its job. It's exactly like a student who crams just to pass a test but forgets everything the next day. They've hacked the test, not learned the subject. The judge AI just gets outsmarted. And that brings us to a totally different way of thinking about this. A really clever idea that just flips the whole problem on its head. It's called reinforcement learning with adversarial critic, or for short, RLAC. Now, the core idea here is actually pretty simple, but it is so powerful. Get this. Instead of trying to check a million different rules, what if you trained a second AI to be a super specialist at finding the single biggest mistake the first AI is making? It's not about checking everything. It's about finding the weakest link, a total game changer. So this whole thing is set up like a game, with three key players on the field. First, you've got the generator. That's the AI trying to do the work, like writing the biography. Then you have the critic, another AI, and its only job is to find what the generator did wrong. And finally, there's the validator. Think of the validator as the impartial referee who comes in and says, yep, the critic's right, or nope, false alarm. And the training loop is just fascinating. Here's how it goes. Step 1, the generator writes something. Step 2, the critic jumps in and says, aha, I think this is your biggest mistake right here. Step 3, the validator, the ref, only checks that one single claim. And finally, step 4, everybody learns. If the critic was right, it gets a point, and the generator learns what not to do. If the critic was wrong, the generator gets the point. So they're constantly locked in this battle, forcing each other to get smarter and smarter. Okay, that sounds awesome in theory, right? An AI sparring match. But does it actually work in practice? Well, let's see what happened when they put it to the test. They picked two really tough, but also really different challenges for RLAC. The first was factual text generation, writing biographies. Here, checking all the facts is possible, but it's a huge pain and super expensive. The second challenge, code generation. And this is a whole different beast, where checking every single bug is literally impossible. So in this setup, both the generator and the critic are big, powerful LLMs. And as they go head-to-head, you get this amazing dynamic. The critic gets smarter at sniffing out really subtle, tricky mistakes, and that forces the generator to step up its game, making its outputs way better and more solid so it doesn't get called out. It's this awesome upward spiral. All right, the moment of truth. How did RLAC actually perform? Let's pull up the scoreboard and we'll start with that biography task. Wow, okay, the numbers here really speak for themselves. If you look at that fact score column, and higher is better, the old school reward model is at about 0.72. The exhaustive method, the one that checks everything, gets a pretty good score, 0.867. But then, look at RLAC. It blows them both away with 0.889. It's just flat out more accurate. Yeah, and when you see it on a chart like this, it's just so obvious. RLAC isn't just a little bit better, it's the clear winner. The quality is just on another level.
But wait, it gets even better. This is the part that really blew my mind. Not only was it the most accurate, it was also way, way more efficient. It needed almost 6 times fewer checks to get that winning score. So think about that. Better results for a fraction of the cost. That's huge.
And this wasn't some lucky fluke. They saw the exact same thing happen with this super hard coding task. RLAC came out on top again, getting the best scores. And get this, it only needed to see about 9% of the training data that the other methods used. Insane. So what's the big takeaway here? It's that by turning training into this competitive game, RLASC found this incredible sweet spot. You get AI models that are more accurate and more reliable, but you get there using way, way less computer power. It's the best of both worlds. And that really leaves us with a huge, kind of exciting question, doesn't it? If making AIs compete against each other is this powerful, if it's the key to making them better, well, where does it stop? What's the actual limit to how smart they can get?